So in demonstrating how to estimate the relationship between two variables, or for short, the term of correlation analysis, we are going to make use of one real-life simple situation here. And in doing so, we all know about sugar levels of patients who have been going to the hospital, or a more popular term known as diabetes. Now, one way of measuring this diabetes is to check for the sugar level of these patients. And in literature, this sugar level has been known to be a major factor once it comes to the age of these patients. So with this example, we are going to look at the age of patients as well as their sugar level. Okay? So let's take a look at this example. So for instance, suppose that we like to test this using 6 patients. So their data has been recorded as, so let's say we have subjects. We also have their age. We also have their glucose level, which is the same as their sugar level. Okay. So just as I said, we are looking for only 6 patients for now, or we have data regarding 6 patients. So we have subject 1, 2, 3, 4, 5, 6. Now with their age, we have 43 for the first patient, 21, 25, 42, 57, and 59. Now for their corresponding glucose or sugar level, we have the first one being 99, 65, 79, 75, 87, and then finally 81. Now suppose that with these two variables that we have here, we like to determine the correlation between these two variables, that is the age and glucose level of these patients. From the formula we used earlier in determining the correlation analysis, the formula, we have correlation of xy, which is equal to the summation from I is equal to 1 to n, then yi into xi minus the mean all over summation from I equal to 1 to n, then yi minus yi all squared times the summation of I equal to 1 to n, then xi minus x bar all squared. Then remember all this as y raised to the power half, which is the same as the square root. Okay? So based on this formula, this referring to the first variable and y referring to the second variable. So relating this to our example that we have here, we can say that our x, let's denote our age by x and our glucose level by y. Okay? So all that we have to do now is to look for, estimate these parameters, just substitute them into this formula, and we are already there. Okay? So let's see. Now, before we can estimate these parameters into our formula, we need about several number of things, okay? Not so many. So first, all that we have to do is just estimate the mean of our first variable, which happens to be our age. Estimate the mean of the second variable, which happens to be the glucose level. Then after that, we have to just estimate this parameter, just find their summations, and we are done. Okay? So let's look at this. Let's see how to determine the summation, which is the same as the total. Okay? Now the total for each of these is equal to 247, and the next one happens to be 486. Okay? Now this is the same as the summation. Okay? Now finally, let's take a look at their averages, which is the same as their mean. So the mean for each of these will be equal to, in the case of the x bar, this will be equal to, for the x variable to be 41.17. Then we have our mean of our y to be equal to just 81. Okay? So now let's see how we get to estimate these variables, okay, or these parameters we have in here. And for me to do that, I will have to clear and give us some space here. Okay. So let me simply write it back here. So we have our R of that is our correlation between the variable x and y being equal to the summation of y equal to 1, come from 1 to n of our I, then xi minus x bar. This is not squared in this case. Then we have summation of I equal to 1 to n to bracket yi minus y bar all squared. Then summation of 1 to n. Then finally xi minus our x bar all squared. And remember all this is being used in the power half, which is the same as the square root. Okay. Now let's see how to get these portions of this variable that we have. Now remember that before we get any of this, first of all we have to look out for the difference between each observation and the mean. Okay, so we have to estimate the difference between each y and its corresponding mean. That is what we have here. And once we have done all that, we have to just multiply the y observation times that of the difference between the yi minus its mean. Okay. Now remember, all these are the summations, meaning that after we've done all this, we just find their summations, and that will be the various components that we have. Okay. So let's try to look at the first one. Now looking at the first one, let's try to tackle this first. Okay. So in this case, we have our xi minus x bar column. Okay. So let's try to estimate these parameters in there. Now with this, all that you are going to do is just take the first observation of xi and just subtract it from the mean. Okay. So with this first row, this is the same as 43. That is the xi minus the x bar. And remember, we have the x bar to be 41.17. So this is just equal to that. And if you should simplify all this, we are getting 1.83. Now if you are to do the same to the second row, that is 21 minus the x bar, which is equal to 41.17. We are getting minus 20.17. Now if you should do same for the other rows, we have minus 16.17, 0.83, then 15.83, then finally we have 17.83. Now that is just for the first part. That is in achieving this part. Let's see how we get to achieve this y part. And this is going to be yi minus y bar. Okay? So let's try to estimate this. Now in doing so, this is yi. So the first one is going to be 99. That is the first value of yi minus the y bar. And we have the y bar equals to 81. Okay? So if you should simplify all this, we are getting 18 for the first instance. Now for the second one too, we just have to take the second value or the second value on this row and just subtract from the mean. Okay? So this is also going to be 65 minus 81. And once we do that, we are also getting minus 16. Now doing same for the other columns, we have minus 2, minus 6, 6, and finally 0. Because each one minus the mean, each one will be as well 0. Okay? So that is just that. Now let's try to estimate one more parameter, which is the yi times the difference between each xi and the mean. Okay? Then after we are going to sum the over what this first part. Okay? So with this is going to be yi, then xi minus x bar. Okay? This is also going to be another parameter. Now remember that we already estimated this portion, this xi minus x bar right here. So all that we have to we just take the value of our yi and just multiply by this value, and that is going to give us this parameter that we have. Okay? So this is just going to be our first row. This is just going to be 99, that is from our y, times our xi minus x bar, which we happen to have as 1.83. Okay? So in simplifying or estimating this, we are having the value of 181.50. If we should do same for the second row, in this case, which we are going to have 65 times minus 20.17. This will be as 2 minus 1,310.83. Now, doing same for the remaining rows, we have negative 127.17. Then we have 62.50. Then we have 137.50. Then finally we have 144.7. Okay? So that is that. Okay? Now, remember that once you come down here, each of these components that we have here has been squared. So it means that you have to find xi minus s bar all squared. Okay? So in doing so, we have xi minus s bar all squared. Okay? And if you look at this portion too has also been squared. So it means that we have to also find the square of this parameter that we have. Okay? After then we are going to sum all this. That is just to calculate the total for each column. Okay? So after we get this done, it means that we also have to estimate our xi minus s bar or square. Okay? And we are done with our calculations. Okay? So with this, our xi minus x bar has already been calculated here. So all that we have to do is just square this parameter or value that we have. Okay? So for this section, this is going to be 1.83 all squared. Okay? And this is going to give us 3.36. Okay? So in place of the whole of this, let's just try to clear this and just write down 3.36. Now the next parameter or the next value for the second row, which is just going to be negative 20.17 squared, and this will land us at 256. Okay? No, this is correct. 406.69. Now the next one, doing same for the similar other rows. This will be 361.36. Then we have 0.69. Then we have 250.69. Then finally we have 180.03. Now squaring the other bars, for the y minus y bar, remember we have these values right here. So all that we have to do is just square this. Okay? So in squaring this, the first one, which happens to be 18 squared, will give us 324. The next one, which happens to be negative 16 squared, will give us 256. Next one happens to be 4. We have 36, another 36. Then finally 0, because square of 0 is still 1, 0. Okay? So now let's see how we get to calculate for this whole parameter. Okay? Now once we come to summation from I to n, which is in this case our n happens to be 6. Now 6, remember 6 is our number of sample size. Okay? That is our number of samples. So summing from 1 equals to 6, meaning that for this first the numerator that we have, that is yi into bracket xi minus x bar has already been calculated at this portion. Okay, so all that we have to do is just sum the whole of what this column, and once we do that, this yields this value as 79.67. Now let's come to the lower part of this. Now with this first lower part, this is trying to sum yi minus y bar. Remember, we are dealing with the square aspect of it, okay? So just summing everything we have under this column. That is the yi minus y bar squared. This will lead us to 109.13. Then finally, summation of xi minus x bar all squared. And remember, once you do all this is going to run as 206.81. Okay? So for now, we have all the parameters that we need. All that we have to do is just add 2 days into the formula, and we are done. Okay? So with this, substituting everything we have into the formula, you can see that our R, that is our correlation between the age and the glucose level, will be equal to the summation of all these parts. And remember, all these parts are calculated as whatever we have here. Okay, that is the summation. So this will be equal to 79.67 all over that lower part of it. Okay, and remember, for the lower part, we estimated this first part as what we have here. Okay, so this will be equal to 109.13. Now remember, it's multiplying this very variable that we have here. Okay, so this will be equal to xi, summation of xi all squared. That is what we have here, estimated at this portion. So all I have to do is just multiply by this 206.81. Now remember, everything we have in here is being raised to the power half. This is the same as what? The square root. Okay. So once you simplify this is just going to give you a numeric value in between the values of what? -1 and +1. Okay. So once we do this is going to land us at somewhere like 0.529809, which is approximately 0.153. Okay. So this is the parameter that we have. Okay. And remember how you get to decide if you have a value, a correlation coefficient just like this. Okay. Now remember that the range started from -1 to +1. Okay. So let's have it as this. Okay. Now let's draw this as a number line. So we have -1 at this point, and we have +1. In between we have 0, and the correlation coefficient we are having here is somewhere 0.53. Now remember, this is in the positive region, so meaning that the glucose level and that of the age of patient are positively related. But now let's look at their strength. Now this is somehow in between 0 and +1. Okay. So with this, we can say that there's some kind of a moderate relationship between these two. Okay. So once it comes to concluding this on this example that we saw, we are going to say that there is a moderately positive relationship between the age of this patient as well as what their glucose level. So this is a typical example of a real life situation where we get to determine the relationship or the coefficient or the correlation analysis between age and the glucose level of the patient. Okay? So this is just the first example, and we are going to move on to the next one.